It is Tuesday, February 17th, 2026. And I want to start by asking you a question, just, between us.
What?
Have you had that feeling recently? Maybe it's at 3 in the morning when you can't sleep, or maybe it's right after you close a news app on your phone.
I think I know the one you mean.
That specific sensation of vertigo, like the ground is actually shifting under your feet.
It's not just you. I think that vertigo is. It's probably the defining symptom of the moment we are all living in.
We are, right now, 18 months into a window of time that our sources today are calling the lock-in.
The lock-in. It sounds ominous.
It kind of is. And if you take nothing else away from this deep dive, understand this. We are in a strategic blink of an eye. The infrastructure, the laws, the code we write in this messy, chaotic year of 2026.
It's going to set the rules for the entire next century.
The entire next century. That's a huge claim.
It is a heavy concept, but think of it like the railroad boom back in the 19th century. There's this brief, explosive period where the tracks were laid down.
A frenzy of activity.
Exactly. And once that steel was on the ground, the economic map of the entire world was basically set for 100 years. If your town was on the line, you thrived. If you weren't,
you became a ghost town.
You became a ghost town.
Sure.
We are laying the digital rails right now, today.
And the stakes, well, the stack of papers on my desk for this is terrifyingly large. But the thesis behind it all is, it's actually pretty simple.
It boils down to one idea.
We are moving from a history defined by scarcity, not enough food, not enough energy, not enough knowledge, to a future defined by abundance.
Yeah.
But we hear that word abundance all the time, especially in tech circles.
Oh, constantly. It's a marketing buzzword.
Right. And usually it just means, cheaper TVs or faster delivery.
Right. But the sources we are looking at today, and I want to be specific here, we're talking about this massive manifesto called Solve Everything. Achieving Abundance by 2035 by Dr. Wisner-Gross and Dr. Diamandis. They aren't talking about consumer goods.
No.
They're talking about the fundamental physics of how civilization works.
So the central question of this deep dive, and it is a real brain breaker, is this. What if scarcity is no longer a resource problem? What if we actually have enough energy? What if we have the atoms to make enough food for everyone? What if the only reason people are hungry or cold is that we have a massive global coordination failure?
That is the hook. That's the entire premise. What if scarcity is just a logistics problem? And what if, for the very first time in 200,000 years of human history, we finally have the compute power to solve the logistics?
Okay. So that's our mission today. We're going to unpack this decentralized renaissance. We're going to look at the theory and solve everything.
Yeah.
But we aren't stopping there. We're going to pair that high-level blueprint.
The view from 30,000 feet.
Exactly. We're going to pair that with the gritty reality of what is happening in the trenches right now. We've got materials from OpenServ and OpenClaw on the agentic economy.
And just to keep us honest, so we don't float away into some kind of utopia bubble, we have the writings of Stephen Wolfram to serve as our anchor.
The buzzkill of physics.
Laughs, the necessary friction of reality. Let's call it that.
Fair enough. Let's start with the thesis then, the war on scarcity. Because the authors of Solve Everything, they frame human history in a really specific way that I honestly hadn't thought about before.
It's a great framing.
They say civilization only advances when we identify a single scarce variable and then build a weapon to kill it.
It's a fascinating framework. I mean, if you look back at, say, the scientific revolution, what was the scarce variable then?
Truth. Knowledge.
Exactly. It was truth. It was knowledge.
Right.
If your crops failed in the year 1600, you didn't know if the soil pH was off or if your neighbor put a curse on you.
Right. You were just guessing.
You were operating in total darkness. The scarcity was ignorance. So humanity built a weapon to fight that scarcity, and we called it the scientific method.
The system.
A rigorous, systematic way to filter signal from noise.
Yeah.
That weapon solved the scarcity of knowledge.
And once you solve one scarcity, you run headfirst into the next bottleneck.
Which brings us to the Industrial Revolution. And the scarce variable there was muscle. Pure physical power.
There's only so much a person or an ox can lift.
Exactly. There is a hard biological limit. You can't argue with biology. And the ox has to sleep, as you said.
Right. It's not a 247 solution.
Precisely. So the weapon we built was the engine. We mechanized energy. We decoupled work from biology. And suddenly we had, for all practical purposes, infinite muscle.
Okay, so then we get to the digital revolution. More recent history.
where the scarce variable was access. The information existed, but it was trapped. It was locked up in physical libraries or fragmented across huge distances.
And the weapon was the internet.
The internet. It dematerialized information and made it liquid, instantly accessible.
Okay, so that brings us to today, Tuesday, February 17th, 2026. What is the scarce variable now? Because, I mean, honestly, it feels like we have too much of everything. I have too many emails, too much news, too much data.
And you've hit the nail on the head. The scarcity isn't data. The scarcity is human attention and purpose.
Our own focus.
Yes. We are drowning in information, but we don't have the cognitive bandwidth to process it. We can't do anything with it because we are bottlenecked by our own brains.
So we have the entire Library of Alexandria in our pockets?
Uh-huh.
But we're too busy scrolling to actually read it.
That's a perfect way to put it. And the weapon to fight this scarcity, according to the manifesto, is superintelligence, or more specifically, what they call the token.
Now, hold on. When you say token, half our listeners are going to think we're talking about crypto speculation or monkey JPEGs.
I know. It's a loaded term. But we have to forget the speculation for a second. In this context, the token represents a unit of executable agency.
Executable agency. What does that mean in practice?
It's the ability to package a task, schedule this meeting, optimize the supply chain, cure this disease, and hand it off to a machine that can execute it without consuming your attention.
So you're offloading the mental work.
It's about offloading the cognitive load. If the engine was about offloading physical labor, the token is about offloading mental labor.
It's a perfect analogy.
It's about creating a frictionless market for getting things done.
So let's play this out. If we win this war, if we actually solve the scarcity of attention, what does the world look like? Because the paper uses this phrase that I find really interesting, the quiet hum.
The quiet hum.
Which sounds, I don't know, peaceful, but also a little bit eerie.
It's meant to be peaceful. Think about electricity. When you walk into your kitchen and you flip the light switch, do you stand there and marvel at the turbines spinning hundreds of miles away?
No.
Do you think about the load balancing on the grid?
Never. I only think about it if the light doesn't turn on.
Exactly. It's boring, it's reliable, it's a utility. That is what Wisner, Gross, and Diamandis define as a solved world.
Ah.
A domain is solved when the bottleneck shifts from human genius to compute logistics. The quiet hum is their vision for the year 2035, where things like health, energy, law, and education just work in the background.
They become utilities?
They become utilities.
That is a wild concept.
Yeah.
The idea that healthcare becomes as boring as tap water. Just turn the tap and the health comes out.
That is the goal. But getting there, that is the chaotic part. That's the vertigo we were talking about. The paper outlines 3 futures, or maybe 3 phases.
Okay.
And we are in the first one right now. 2026, the lock-in.
That's us, standing on the cliff's edge.
That's us. And it's described as a battle between the muddle, which is their term for bureaucracy, red tape, the old way of doing things.
The muddle. Love
And
it.
the targeting authorities, which are the new systems trying to build this abundance.
The muddle. It sounds like a swamp monster from a children's book.
It acts like one. It's sticky. It slows you down. It sucks you in. Then, if we get through this, you have 2030, which they call the liquefaction.
The liquefaction.
That's the messy middle where the old institutions, the banks, the hospitals, the universities, they start to melt down because they just can't compete with the new efficiency.
A chaotic transition period.
Very. And then finally, if all goes well, 2035 brings the quiet hum.
Okay, so we are in the lock-in. We are fighting the muddle. How do we actually fight it? The paper talks about this concept of industrializing discovery. This is a huge shift in mindset for me. They say the lone genius is dead.
This is a really hard pill for a lot of people to swallow, especially in the West. We are raised on the great man theory of history. You know, the Tesla, the Edison, the Einstein. We love the story of the guy in the garage having a eureka moment.
Artisanal intelligence.
Yeah.
That's the phrase they use.
Exactly. Handcrafted discovery. But the argument here is that the lone genius model just doesn't scale. It can't solve problems fast enough.
Why not?
Well, think about how we do science right now. You have a brilliant PhD student. They spend 5 years studying one specific protein.
Right.
During that time, they have to sleep, they have to eat, they have to write grant applications, they get depressed, they have a eureka moment maybe once, they publish a paper. It's slow. It's painfully slow.
It's inefficient.
It's tragically inefficient. The shift to industrialized discovery means we stop waiting for the genius to have a brilliant idea. Instead, We build a system, they call it a harness, that allows millions of AI agents to attack the problem from every possible angle simultaneously.
So you're not looking for the needle in the haystack anymore.
No.
You're building a machine that magnetically pulls the needle out in a millisecond.
Or a machine that just burns the haystack down until only the needle is left. The hero of this news story isn't the scientist who finds the cure. It's the harness builder. It's the person who builds the platform that allows the cure to be found by the system.
That's a profound shift in who we celebrate. It's the tool maker, not the user.
It's the architect of the system.
Which brings us to this abundance flywheel. I really want to walk through this because it seems like the engine of this whole theory. There are 5 steps to industrializing discovery.
Right. And step 1 is commitment. This is totally different from how we usually do science. Usually, you're begging for funding, you're writing grants.
Yeah, the song and dance.
Here, commitment means pre-committed compute, or capital that's already locked in escrow. The money is there. It's sitting in a smart contract waiting to be claimed.
It's a bounty, a prize.
It's a guaranteed bounty, which leads to step 2, focus. You aim all of that R&D at a very, very specific target, not something vague like explore cancer.
No, it has to be measurable.
It has to be incredibly specific, like find a molecule that binds to this specific protein receptor with an affinity of X.
Specificity matters. You have to tell the machine exactly what winning looks like.
Crucially, if you can't define the win condition, you can't solve it this way. Step 3 is domain collapse. This is the moment the target is cleared, the problem is solved, the bounty is won.
And what happens then?
Step 4 is surplus. Solving that problem creates massive economic value. I mean, think about curing a major disease.
Trillions of dollars in value.
Exactly. And that leads to the final step, step 5, reinvestment. That value, that surplus, it flows immediately into the next, even harder target. It funds the next bounty.
It's a compounding loop of problem solving.
And it absolutely relies on what they call targeting authorities. These are the bodies, they could be public, they could be private, that define the benchmarks. They're the ones who say, here is the prize. Fix this pothole to these exact specifications. Cure this pathogen.
And they use a mechanism called blinded clears. I want to pause on this because it sounds technical, but it's actually really important for trust, isn't it?
It is. It's the whole ballgame. Imagine a teacher giving a test. If the student has seen the answer key beforehand, getting an A is completely meaningless.
Of course. They just memorize the answers. It's cheating.
Blinded clears means the targeting authority holds back the validation data. The AI has to prove it solved the problem on data it has never seen before. It's a double-blind test for algorithms.
So you can't cheat.
You can't cheat. You can't just teach to the test. You have to have actually solved the fundamental physics of the problem to win the prize.
So if an AI claims it can predict a heart attack based on an EKG,
it has to predict it on 1,000 EKGs that were kept in a vault that it has absolutely no prior access to.
and if it gets it right,
The smart contract triggers, the money is released, boom, problem solved. There are no grant committees, no peer review politics, no human bias, just results.
this changes how we think about capital too. The paper mentions this new metric, ROCE's return on cognitive spend.
Yes. Move over EBITDA. This is the argument. ROCES is the metric of the 21st century. Companies and even entire nations will be measured not by their profit, but by how much value they create per watt of energy and per unit of compute used.
So you're treating compute not as an IT expense like your electric bill,
Right.
but as working capital, as an investment.
It's the core asset. The paper has a great line. Treat compute as ammo.
Treat compute as ammo. I like that.
You are firing compute at the problem of scarcity until it's gone.
So that is the theory. That is the high-level view from 30,000 feet. But I want to land the plane now. I want to talk about what this looks like on a Tuesday in 2026. We've got these sources from OpenServ and OpenClaw. This isn't theoretical manifesto stuff. This is software running on servers right now.
This is the engine chapter of the story. This is the agentic economy, and it's already being built.
One of the core ideas in the OpenServ material is what they call the entrepreneur's problem. And boy, does this resonate with me. It says the current model of one human doing everything, the marketing, the coding, the finance, the legal stuff, it's broken.
It's unsustainably broken. We have reached the absolute limits of human cognitive bandwidth. I mean, think about the modern founder.
Detestable.
They're expected to be a visionary leader, a CFO, a social media manager, a recruiter, and a world-class product designer. It's a recipe for burnout.
It's what they call the bandwidth tax. Every
Yep.
time you switch tasks, you lose efficiency.
Right. So OpenServ pitches this idea of the autonomous startup. The idea is that humans provide the what? The strategic oversight, the North Star, the vision, and a swarm of AI agents handles the how all of the execution.
They break it down into 3 levers of leverage.
Yes. Leverage over software, which is building the product. Leverage over capital, which is launching it and funding it. And leverage over labor, which is running the day-to-day operations.
Let's get specific, though. How does this actually work? Because AI agent is a buzzword we hear constantly. It's everywhere. What does an agent actually look like in this economy?
So we are not talking about a chatbot you talk to. We're talking about fractionalized autonomous entities. Imagine a marketing agent. It's a piece of software that has its own wallet, it has a clear mandate, and it runs 24/7.
And what does it do?
It optimizes ad spend across 20 platforms. It writes 10,000 versions of copy. It analyzes market trends while you're sleeping. And here's the kicker. OpenServ's documentation outlines how they allow for fractional ownership of that agent.
Wait. So I can own shares in a marketing bot?
Exactly. Imagine there is the world's best sales agent. Let's call him BobBot. BobBot is just incredible at closing B2B software deals.
Right.
You don't hire BobBot. You buy tokens in BobBot. You invest in him.
So I'm investing in the labor force directly, in the means of production, but the production is cognitive.
You are capitalizing the labor itself. And BobBot can work for 1,000 different companies simultaneously. Every time he closes a deal for any of those companies, a tiny dividend flows back to your wallet.
That is mind-bending.
Yeah,
It completely decouples the ability to earn from the requirement to do the labor yourself.
precisely. And it goes even deeper. They talk about these things called shadow agents.
It sounds incredibly spy movie. The shadow agents are a go.
It's actually just about efficient infrastructure. Shadow agents are the invisible facilitators. They operate in the background. So let's say your primary marketing agent needs to pay for a specialized data set to finish a report.
Right.
You, the human, you don't want to be pinged to approve a 5-cent transaction. It's a waste of your attention. A shadow agent handles the negotiation with the data provider agent, handles the payment, and integrates the data, all without bothering you.
It's the grease in the gears. It removes all the friction from the machine-to-machine transactions.
Exactly. And to do that, they need a banking system. That is where the B402 protocol comes in.
Which solves, as they say, the original sin of the internet.
The original sin was that we never built a native payment layer into the web. We built it for information, not value. We just tacked on credit cards decades later, and it's clunky.
Yeah, it's a mess.
B402 is a protocol that's designed to allow agents to pay other agents via micropayments. It essentially gives every AI a bank account.
So the agents can trade labor with each other. I'll analyze this data for you if you write the summary for me, and a fraction of a cent changes hands instantly.
Correct. It creates a high-velocity machine-to-machine economy that operates at speeds and scales that humans just can't even comprehend.
But, and there's always a huge but, here we all know that AI hallucinates. It makes stuff up. I've heard it described as a brilliant improviser who's also slightly drunk. How in the world do we trust these agents with our bank accounts and our companies?
That is the multi-billion, maybe multi-trillion-dollar question. And the OpenServ materials, they point to a solution called the B.R.A.I.D framework.
B.R.A.I.D. That's an acronym. B.R.A.I.D. What does it stand for?
It stands for Bounded Reasoning for Autonomous Inference and Decisions.
Okay, that's a mouthful. Can you break that down for us non-engineers?
I can. It's actually a brilliant concept. The problem with large language models, LLMs, is that they are probabilistic. They operate on what's called chain of thought. They just kind of ramble their way to an answer. They're just guessing the next most likely word.
Which is fine if you're writing a poem, but it's really, really bad for managing a company's ledger.
Exactly. B.R.A.I.D forces the AI to use something they call algorithmic scaffolding. Think of it like a pilot's pre-flight checklist.
Okay.
You cannot take off until you have physically verified that the landing gear is down, checked the flaps, confirmed the hydraulics. B.R.A.I.D forces the AI to follow a rigorous, structured, provable logic path. It can't just guess. It has to show its work at every step.
So it puts the drunk genius in a straitjacket of logic.
Laughs. Or just sobers him up, maybe. The source data here is fascinating. It indicates that on complex reasoning tasks, like the GSM 8K benchmark, which is high-level grade school math, but it's very tricky.
Right?
Standard chain of thought prompting gets about 40% accuracy.
That's a failing grade. I mean, that's completely unusable for anything important.
It's a toy. But with B.R.A.I.D, with that algorithmic scaffolding, the accuracy jumps to roughly 91%.
91%.
Yes.
That is the difference between a toy and an actual reliable employee.
Exactly. It turns the drunk genius into a reliable operator. And that reliability is what underpins the entire possibility of the quiet hum. You have to trust the system.
So we have the thesis, which is solve everything. We have the engine, which is OpenServ, and the agentic economy. Now let's talk about the bad guys, or at least the obstacles. The paper identifies this villain called the Muddle.
The Bureaucratosaurus.
The Bureaucratosaurus. I feel like I've met him at the DMV a few times.
We all have. The Muddle is that entrenched layer of bureaucracy that measures inputs rather than outcomes. It cares that you filled out Form 27B in triplicate, not that the problem was actually solved.
It values hours worked over potholes fixed.
Perfectly put, it's process over progress. And the conflict right now, in 2026, in this lock-in period, is that the bureaucracies are freaking out.
They're panicking.
They are panic regulating. They are trying to ban these unsupervised agentic loops. They're trying to regulate the machine economy out of existence because they can't control it, they can't see it, and it doesn't fit in their boxes. They want a human in the loop for every single tiny decision.
And the paper makes this incredible comparison. The future could be a super intelligent DMV, or it could be the Star Trek economy.
And that choice is being made right now. If we hard code our existing bureaucracy into our artificial superintelligence, we just get a machine that can reject your permit application in 0.0001 seconds for a typo on line 32.
That is the superintelligent DMV. It's my nightmare.
It's hell. The alternative is to code for outcomes, to strip away the process and focus only on the result.
But there is another obstacle. A much harder one that you can't just legislate away or out-innovate, and that's physics.
Enter Stephen Wolfram.
The man who thinks in code. We brought his writings in as a necessary counterweight because the solve everything guys are, let's be honest, extremely optimistic.
They are, and Wolfram provides a necessary reality check, a dose of, well, computational reality. He asks a fundamental question. Can AI actually solve science? Can it just look at the universe and predict the final answer?
And his answer is no. Is that right?
His answer is not everything.
Okay.
He introduces this really profound concept called computational irreducibility.
Okay, this is a dense one. I want to make sure we get this right. Can you break that down?
Let's try. Imagine a billiard table with just one ball on it. If I hit that ball with a certain force at a certain angle, you can use a simple Newtonian formula to predict exactly where it will be in 10 seconds.
Simple physics. I remember that from high school.
You can reduce the problem. You can jump ahead to the end without simulating every nanosecond of its journey.
Got it.
Now imagine the weather, or the evolution of a species, or the famous three-body problem in physics. To know what happens next, you actually have to simulate every single step of the interaction. You can't just skip to the end. There is no simple formula that predicts the exact state of the weather a year from now.
You have to live through the year to know what happens.
Exactly. The universe is the computation. And if the AI is part of that universe, it can't run faster than the universe itself in a meaningful way for those specific irreducible problems.
So AI isn't a magic wand. It can't just say, let there be light and solve the fundamental nature of reality.
No. However, and this is the key nuance, this is where Wolfram and Diamandis might agree. Wolfram admits that AI is absolutely incredible at finding what he calls pockets of reducibility.
Shortcuts.
Exactly, shortcuts. There are huge chunks of science and engineering like protein folding with AlphaFold, or code generation, where we thought it was irreducible. We thought we had to brute force simulate every single atom.
But it turns out there were patterns we couldn't see.
Patterns, rules, shortcuts. And AI is a pattern-finding machine unlike anything we've ever built. It finds those pockets of reducibility and exploits them.
So the synthesis here is, we can solve human-level narratives and engineering problems. We can cure diseases, we can build fusion reactors, we can fix the grid, but we cannot solve the infinite, irreducible complexity of the universe itself.
That's a perfect summary. There will always be surprises. There will always be the unknown unknowns. We can build a Star Trek economy, but we probably can't become gods who know the position and fate of every atom in the cosmos.
You know what? I think I'll settle for the Star Trek economy.
I think most of us would. It's a pretty good deal.
Let's talk about the specific missions then. The moonshots. The paper lists about 15 of them, but let's focus on the really big ones. They describe something called a solution wavefront.
Which is just a fancy way of saying you have to fix things in a specific order.
Right. You can't build a house starting with the roof.
Exactly. Information first, then you can manipulate the physical world, then you can manage planetary systems. You have to fix the code before you can effectively rearrange the atoms.
One of the moonshots that really stood out to me was solved biology.
This is a huge one. This is the proposed shift from our current system of sick care to a future of universal biofactories.
The idea that we could print organs on demand, is that what they mean?
Print organs, design and cure pathogens on demand, personalized medicine. The core idea is to turn biology into a true engineering discipline. Right now, it's more of an art. If you can model the cell perfectly in a computer, finding those pockets of reducibility, you can simulate a cure in silicon before you ever touch a human patient.
You debug the human body like it's a piece of software.
That's the goal.
And then there is energy abundance. How does that one work?
This links back to the compute. They talk about schedulable compute. We usually think of data centers as these massive energy drains on the grid.
They are, right.
They are today. But in this model, you should think of data centers as batteries for the grid, as a stabilizing force.
How does that work? How can a data center be a battery?
When the sun is shining and the wind is blowing and you have a massive surplus of cheap renewable energy, the data centers crank up to 110%. They do massive calculations, they train new models, they run scientific simulations, they soak up all that excess energy.
And when the sun goes down?
When energy is scarce and expensive, they instantly power down their non-critical tasks. They shed load in a microsecond. They act as a dynamic ballast that stabilizes the entire grid, making renewables far more practical.
And the last one I wanted to touch on, planetary gardening.
This is the most controversial one.
It sounds incredibly arrogant. We are going to garden the earth.
It does sound arrogant. But the argument in the paper is this. We are already affecting the weather and the biosphere. We're just doing it blindly. We are driving the car with a blindfold on, swerving all over the road.
So planetary gardening just means taking the blindfold off.
It means taking the blindfold off. It means accepting responsibility for the climate and managing it actively and intelligently, rather than accidentally and destructively.
Now, to do any of this, to garden the planet or solve biology, intelligence needs hands. We can't just have a super smart brain in a jar.
That is where action networks come in. This is the physical robotic layer. Imagine you have an AI that designs a new material, a new room temperature superconductor, let's say.
The Holy Grail.
It's just code on a server. So it sends an API call to a robotic lab in New Jersey.
A robot chemist.
Exactly. A fully automated lab. That robot mixes the specified chemicals, synthesizes the material, tests its properties, and sends the raw data back to the AI.
And the AI learns from the result.
It learns, it adjusts the formula, and it sends a new instruction. This is the accelerated closed-loop scientific method.
And the humans. The humans are asleep while this is all happening.
The humans are asleep and the machine is running 10,000 experiments a night. That is how you solve scarcity. You don't just speed up the genius, you industrialize the entire loop of discovery.
Okay, let's fast forward. Let's say we pull this off. It's 2035. We beat the Muddle. We built the rails. We've launched the moonshots. What happens to society? Because if the robots are doing the physical work and the AI is doing the thinking, do we all just sit around and watch Netflix?
That's the big question. The paper talks about the need for new metrics for a new world. First, they argue that GDP, gross domestic product, is completely obsolete.
Rest in peace, GDP. I don't think many people will miss it.
It measures transaction volume. It measures friction. If you get cancer and spend $1 million on chemotherapy, GDP goes up. That is a terrible metric for the health of a society.
Right. We want a metric where curing cancer for $5 is the win.
Precisely. So they propose the ACI, the Abundance Capability Index.
And what does that measure?
It doesn't measure how much money changes hands. It measures a nation's potential to solve problems. What is your energy to compute advantage? What is your data advantage? What is your population's access to problem-solving tools? It measures capacity, not friction.
And what about for the individual? The paper proposes something called Universal Basic Capability, or UBC. How's that different from UBI, Universal Basic Income?
It's a critical distinction. UBI is about giving people cash, but in a world of hyperinflation or rapidly changing economics, cash might lose its value. If the rent for your apartment triples, your UBI check is suddenly worthless.
So UBC is different.
UBC is different. It guarantees access to the solved domains.
Access to what specifically?
It guarantees you access to the best AI doctor in the world, the best AI tutor for your kids, the best AI legal counsel, the best AI financial advisor.
Because the marginal cost of providing that software is essentially zero.
Exactly. Once the software is written, copying it is free. So we don't give you money to buy a doctor, we give you the doctor. We demonetize the fundamental costs of living a good life.
And they also mentioned a compute wallet.
Yes, this is key. It's not just about passive consumption. Every citizen gets an allowance of compute. You get a quota of machine intelligence that you can command.
So I'm not just a consumer.
You're not. You have the tools to build your own visions, to start your own autonomous company, to run your own scientific experiments. You are an active participant.
So my role as a human in this world, it shifts dramatically.
Yeah.
I'm not the worker bee anymore. I'm not the calculator. I'm the commander, the visionary.
You become the explorer of purpose. The AI can tell you how to build the bridge, but it can't tell you why you should build the bridge or where it should go. You set the North Star. You decide what is worth building.
And you also become the
creator of meaning, art, culture, community, relationships, all the things where human subjectivity and lived experience are the only things that have value.
An AI can write a song that sounds like Bob Dylan, but it can't have a messy breakup in Greenwich Village in the 60s that inspired the song.
Exactly. Meaning is our monopoly. We stop competing on muscle and calculation, and we start competing on pure humanity.
This brings us to the end, the outro of the paper and of our deep dive today, the final vision of the quiet hum.
It's what they call the snack. It's that moment when progress shifts from rhetoric, from podcasts like this one to routine. It's when you stop talking about the revolution because you are simply living in it. The technology becomes invisible.
And the call to action from our sources today is pretty clear, isn't it?
It's very direct. Buy the primitives, not the models. Don't invest in the specific chatbot that's hot this week. Invest in the rails. Invest in the targeting systems, the audit trails, the energy infrastructure, the boring stuff.
And for you, the listener,
Yeah.
for us, the advice is to stop the innovation theater. Stop having endless meetings about AI.
And start shipping targets. Define a problem you want solved. Set the reward. And let the machine solve it.
It is a lot to process. It's incredibly optimistic. It's also a little terrifying, and it's happening so fast. But if there's one thought to leave you with today, it's this. The Industrial Revolution was a war on muscle. This is a war on scarcity. If the tools to solve everything are being built right now, literally as we speak, the only question left is, what outcome are you going to pay for?
Pick your target.
Thanks for diving deep with us. We'll see you in the future.
Hopefully solved one.